Okay, let's give you guys some more practice. So here we've got a graph of y equals x squared. So this line here is y equals x squared. A here could be anywhere. So A could be here, A could be here, A could be anywhere. Come up with an equation for this area here. Okay, for this purple area. So remember, A could be anywhere. Well, anyway, come up with an equation for this area here. So press pause and have a go. Okay, so to do this, there are several ways of doing this. So the first method is for us to work out the area of this triangle here, and then take away the integral so the first method is to work out the area of this triangle. Okay, so if this here is A, then this must be square root of A. Okay, because if this is a square root of A, you would then square it to give you A. Well, if this is A, then therefore this point here must be root A. Okay, so this point here is root A. So if you want to know this whole area here, you would get the height here, which would be A times root A. So it would be A times root A, and then cut in half. That will then give you the area of the triangle. But then you need to take away this area here. So then you need to take away the integral from 0 to A, from 0 to root A. So this bit here is root A, from 0 to root A of x squared dx. Okay, so you need the triangle here. You need the triangle. Take away that. So this is one way of doing it. Okay, so the first method would be us. So because this is an even function, then let's just concentrate on finding out the area of this, and then right at the end we can times it by 2. Okay, that will then give us the whole thing because it's an even function. So the first method, work out the area of the triangle, and then take away the integral of the x squared. Okay, so this here is the first method. So half of that area would be us doing this. So this here is our triangle. Okay, and then take away this thing, and then integrate it. Okay, so integrate this. It would be this, and then from 0 to root A. Okay, and then blah blah blah. Tidy up, and then it should give you so half of an area equals this. So therefore, both sides would be this. Okay, you times both sides by 2 here, and it will give you this. Okay, so this is one method. Second method would be this. Second method would be so the second method would be for us to integrate the difference of the two. Okay, so the difference of the two, you would get this line here. Take away the x squared line. Okay, so what is the equation for this straight line? Well, it's a straight line, so it's going to be this straight line here, which is also pretty much the same as this line here. Well, the equation for this straight line here will be, well, it's a straight line, so it must obey this, y equals mx plus c. And then, well, what is the gradient? What is the gradient of this? Well, the gradient would be the height, which will be a, divided by the across, which will be root a. So the gradient, so the height here would be a, the across here would be root a. So now, if you get a divided by root a, then that's the same as a to the power of 2 over 2 divided by a half here. So now just get this, take away this, so that would be a to the power of a half, which is root a. So the gradient here is root a, no matter where a is. A could be here, a could be here. Regardless of where a is, the gradient will always be root a. So now that you know the gradient, you can put it into here. So the equation of that straight line will be given by this. Okay. Well, you know the intercept here is 0. It goes through the origin. So the equation of this line here is given by this. So doing it this method, where you when you integrate it vertically, so it would be the integral from 0 all the way across to root A, and then it would be the straight line. It would be this straight line here, which would be root AX, and then take away x squared, and then dx. So it's you trying to evaluate this. Okay, well, how? So the area here is given by this. You can set it up as this. Okay, so that's from 0 to root A, and then blah blah blah, integrate it, and it will give you the same answer. The third method is to do it horizontally. So the third method, so remember the equation of this straight line is given by this. So the third method would be us integrating like this. Okay, so the thickness here, the thickness of this rectangle here is dy. So doing it horizontally, it would be doing it horizontally. We're integrating from 0 to A. So we're integrating from 0 to A. And then what is the across here? Well, basically we want to know this length here. Well, the across here, well, from here to here, it would be looking at this here. It would be root y equals x. So this length here is root y. It's root y, and then from here to here, from here to here, it would be us using this. Okay, so that would be y divided by root a. So this length here, from here to here, it would be y over root a, because this, divide both sides by this. So from here to here, it is y over root a. So if you want to know what's in between, it would be this. What's in between would be root y, take away this. So the length from here to here is root y. The length from here to here, it would be y over root a. So what's in between would be this, take away this, and then you're integrating it from 0 to a. You're integrating it from 0 all the way to a. Okay, but this time by dy. Okay, so follow the whole thing through, and it will give you blah 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 blah, and it will give you the same answer. Okay, so there are three. I'm sure there are other methods as well. Okay.